Notes 5.5, Proportional and Non-Proportional Relationships. The objective is to identify proportional and non-proportional relationships in tables and graphs, and to describe a proportional relationship using an equation. Core state standards are listed in our mathematical practices. The first thing that we're going to do is we're going to define our vocabulary words. So the first word is proportional. In the definition it is if two quantities have the constant ratio or unit rate of y over x. So an example would be if we have 4 over 2, that is equal to 2 over 1. It's proportional because if we reduce the 4 over 2, we get 2 over 1. And we can see that our unit rate would be 2 over 1. Non-proportional definition is if two quantities do not have a constant ratio or a unit rate. So if we have 12 over 6, and that is equal to 10 over 2. If we reduce these, we get 6 over 1. Is that equal to 5 over 1? It is not proportional. The unit rates are not the same. The constant ratio is not the same. Constant of proportionality definition is the constant ratio or unit rate where we have y over x. And the constant ratio variable to identify it as k, and we want to have y over x. The constant ratio is y over x. So in the first example, the constant ratio would be 2 over 1. Identify proportional relationships. The distance traveled is proportional to the time. State the constant of proportionality. So in our table, we have our time in minutes, which is our x value, and our distances in yards, which is our y value. We want to figure out the constant of proportionality. The constant of proportionality is your y over x. So we take our y value, which would be 300 over 1, which is simplified. So that's also your unit rate, 300 over 1. Now we go to our second minute, which would give us our 600, our distance, over 2. And if we simplify it, 300 over 1. Then we have our 900 over 3, which simplifies down to 300 over 1, and 1200 over 4, which gives us 300 over 1. Since our constant of proportionality remains the same, 300 over 1, this is proportional. So it's proportional, and we have 300 yards over 1 minute. Or your k constant is equal to 300 over 1. 2. Determine whether the A, cost of the coffee, is proportional to the number of pounds. If the relationship is proportional, identify the constant of proportionality. So in our problem over here, our coffee is your x value in pounds, and the cost is your y value in dollars. To figure out your constant of proportionality, it's your y value over your x, so our dollars over our pounds. So number 1 is 3 over 1. It's already simplified. The second one we have 6 over 2, which reduces down to 3 over 1. Then we have 9 over 3, which simplifies down to 3 over 1. And 12 over 4 gives you 3 over 1. So our first part is the coffee proportional to the number of pounds, and that would be yes. And our constant of proportionality would be 3 pounds over $1, or we would have our k is equal to 3 over 1. That is also your unit rate. Determine whether the distance in miles is proportional to the time in hours. And B, if the relationship is proportional, identify the constant of proportionality. So we have our time in hours is x, and our distance in miles is your y. So we would take to find your constant of proportionality, that's your y over x, so that would be 50 over 1, which is simplified. Then we have 70 over 2, which simplifies down to 35 over 1. Then we have 90 over 3, which simplifies down to 30 over 1. Since we have our first constant of proportionality, to 50 over 1, and our second 35 over 1, and then 30 over 1, these are not proportional because our 50 over 1 does not equal 35 over 1, which does not equal 30 over 1. So this does not have a proportional relationship between our time and our distance. The next section is use proportional relationships. So we have our vocabulary word, and you're going to fill in your definition. We have a proportional relationship, and the definition can also be described using the equations of the form y is equal to kx, where your k is your constant ratio, your constant of proportionality, y over x. So our k is equal to y over x. That's your constant of proportionality. All right, our next section says solve. Gloria earned $26 for babysitting for 4 hours. And you're going to set it up as money earned to hours. We're going to find the constant of proportionality. So we take our money earned, which is $26, and we are going to put it over the number of hours. That gives us $6.50 per hour. That's your constant of proportionality. The rate of pay Gloria is earning each hour is $6.50. Part B says, then write an equation relating money earned to the number of hours. So we want to have our x equal to your hours and our y equal to your money earned. You are going to use the formula y is equal to kx. We just figured out what our k was. Our k was the $6.50. So we're going to substitute that into the equation. So $6.50, and we are going to multiply it by your x. We don't know how many hours we have right now, and that is going to give you your money earned. So in part B, we can use the equation to solve how much would Gloria earn after she babysat for 25 hours. Hours is your k value, so we can substitute that in. So y is equal to $6.50 times 25. So that's your constant of proportionality, your 650 times your number of hours. So this is your k to 650. Your hours is your x. So to get our y value, which is the money earned, we multiply $6.50 times 25, representing your hours, to give you $162.50. And that is for 25 hours of babysitting. Number 2. The cost of 2½ pounds of meat is $7.20. And we want to represent this cost to pounds. We want to find the constant of proportionality. So we want to put our cost, $7.20, over your number of pounds. And we can convert that to a decimal, 2.5 pounds. When we divide that out, the cost of the meat is $2.88 for 1 pound. So that's also your unit rate. That equals your K, your constant of proportionality, how much the meat costs per pound. Now we're going to write an equation relating costs to pounds. Your X is your pounds, your Y is the cost. Using the formula, Y is equal to KX. Your K is your constant of proportionality, which is your $2.88 found in your last problem. We multiply it by the X, because we don't know how many pounds yet, and that would give you the cost. So there's your equation. Now, in part C, we're going to figure out how much will 4 pounds cost. So we have Y is equal to your $2.88 for 1 pound, but we want to find out what it costs for 4 pounds. So when we multiply the $2.88 times 4, we get $11.52 for 4 pounds.